Alright, so for number 7, it says use the data in the table along with your calculator to find an exponential regression. So we've looked at the tables before in the calculator, but we're going to do an exponential regression model for the U.S. population, and we want to predict the population in 2015. So because we have the list here, we're going to make the list in our calculator. So we're going to put in L1, we're going to put the year, and in L2, we're going to put the population. Now, you can't put like 1900 as your year. You have to put like your starting year. So we really need to put a T here. So like 1900 would be our start. So we'll put that as 0. So 1910 would be 10. Then this is just 20, 30, 40, 50, 60, 70, 80, 90, 100, and then 107. The purple numbers are the ones that you need to use in your calculator, not the actual years. So in your calculator, let me make my calculator a little bit smaller here. Okay, so in your calculator, we're going to go to Stat, and then you're going to go to Edit, which is the first thing. And then in L1, you're going to type in those numbers. So we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 107. And you just want to make sure you got them all correct, and we do. So then in L2, you're going to type in the population. So 76.2, 92.2, 106, 123.2, 132.2, 151.3, 179.3, 203.3, 226.5, 248.7, 281.4, and 301.6. And you just want to make sure that you have the correct numbers there. Okay, so once you have these typed in, then you're going to go to Stat. And you're going to go over to Calc. And because it wants us to make an exponential regression model, you want to find the one that says exponential. So you're going to go down to number 0, which says EXP regression. You're going to hit enter. L1 and L2 are correct, so enter, enter, enter. And when it gets to calculate, you hit enter. And it should give you the equation here. Okay. So I'm going to move this over for a second here just so we can see. I'm going to write this stuff down. So we had, make sure in your calculator you went to Stat, you went to Edit, then you type this into L1 and L2, and then we hit Stat, Calc, and then we picked 0, which was exponential reg. So whatever kind of function it tells you to make is what you do there. And then now, from what we have on our calculator there, you can see the formula is y equals ab to the x power. Well, it tells you that the a, and if we round to 3 decimal places, is 81.041. And then our b value is 1.013. And that would be to your x power. So that is your exponential equation there. So then it says predict the population in 2015. So 2015, and we started in 1900. In 2015 is going to be a t value or an x value of 115. So if we plug that in here, really it's the x value, but 81.041 times 1.013 to the 115. And now we're just typing that into the regular calculator part. So we're just going to type in the 81.041 parentheses 1.013, and that's going to be to the 115th power. And that gives us 357.924. Now, if you notice over here in the population, it does tell you that the population is in millions, so this is actually millions. All right, so that's how you can use the table that we've looked at before and make a exponential regression model there. Okay, so now we're going to move on to, instead of exponential, we're going to look at some logistic functions. So for number 8, we want to write a logistic function that has initial value 16, limit to growth is 128, and it passes through the point 532. Okay, so the formula, and I will give you this formula for logistics, is y equals c over 1 plus a e to the negative kx. So that will be given to you. Okay, so the initial value is 16. And so what that means is, and then our limit to growth, remember, is c. So our c value is 128. So the initial 16, that happens when x is 0. So if we make our equation here, y equals, we know that c is 128, so I'm going to go ahead and plug that in, 1 plus a e to the negative kx. So I've used my c equals 128. Now I'm going to use this information about the initial. So the initial is 16, so that means the y value is 16 whenever I plug in 0 for x. Well, when you plug in 0 for that x there, that's going to make this part just be 1. So you really have 16 equals 128 over 1 plus a. So that's going to allow us to cross multiply here. 16 times 1 plus a equals 128. So 16 plus 16a equals 128. So if I do 128 minus 16, 16a equals 112. So if we divide by 16a is going to be 7. Okay, so here's what we have now. For our formula, y equals, our c value is 128, 1 plus, now we know our a value is 7, e to the negative kx. So the last thing that you have to do here is you're going to take the point that they give you, and that's your x and your y value. That will allow you to plug in the x and y, and then you can solve for k. So the y value is 32, was 128 over 1 plus 7e to the negative k times your x, which is 5. So because we have two things that are equal to each other, we're going to put one side in y1 and we're going to put one side in y2, and we're going to find where they intersect. So on your calculator, I'm going to go to your y equals. So in my y1, I'm going to put the 32. My y2, I want to make it a fraction, so I'm going to hit math and go all the way over to fraction. That'll let you set it up exactly like it looks. So 128 over 1 plus 7 e. So if you want to use the e with the exponent, that's on ln, and the exponent is negative k times 5, so I'm going to put negative 5x. So we have to use an x for that k there. Now, in our window, this is going to be a really small number, so I'm just going to put x max as 10, and this will always give you a small number because it's the k. And then remember the y max was the 32, so I'm just going to make it 40 there. So let's see, as long as we can see them cross, and we do. So we're going to do our intersection. So second, trace, intersect, which is number 5. You're going to hit enter 3 times. And so this is going to give you your k value, and like I said, it should be a really small number, and it is 0.169. So k is 0.169. So now we can finally go back and write our equation. So our final answer is going to be y equals, we're going to have 128 for c, 1 plus a, which is 7, e. Now, when you have your k value here, notice it is negative k, so it's going to be negative 0.169 times x, and that is our equation of our logistics function. So guys, for this, a couple things that you just need to make sure of. You'll be given the equation. Your c value always goes on top there. Okay. Then you're going to take your initial, plug in what the initial is for y and 0 for x, then you can solve for a. Now you have a new equation. You're going to take your new equation and plug in the point they give you. You're going to have to use your calculator, and then you can get what that gives you. And it's always going to be a negative in your exponent. Okay, so these problems are a little bit easier. So they give us the logistic function. So if we want to figure out the initial population, so remember initial is when x is 0. So we're really just plugging in 0 here. So if we plug in 0 for t, well, anything to the 0th power is 1. So it's really 1001, 20 zeros there, over 1 plus 90. So it's, because that would just be e to the 0. So it's really just 1001 over 91, which will give you 11. So 11 deer is how many that we had initially. So initially is just when x or t is 0. Sorry. So what we did was we just plugged in 0 here. So then for part B, when will the number of deer be 600? So we're trying to find t, and we want to know when it's equal to 600. So p of t is going to be 600. We'll have 1001 over 1 plus 90 e to the negative 0.2 t. So because we're trying to figure out where these two things are intersect, you're going to put 1 in y1 and 1 in y2. So I'll bring my calculator back up here. So if we go to our y equals, so in y1 I'm going to put 600. In y2 I'm going to go to math and go over to fraction. Then I have 1001 over 1 plus 90 e, which is on ln, to the negative 0.2x. Now for my window, x max, I'm going to change that to 100 this time. And then my y max needs to be bigger than 600, so I'm just going to change it to 1000. So we're just going to find where these intersect. We're going to do second trace intersect. And that should give you 24.514. So our t value is going to be 24.514. And I'm just going to keep the decimals, and that is in years. And then the last one for this says, what is the maximum number of deer possible in the park? So they're talking about what is C. Well, because this is 1, remember, as long as this is 1, C is just whatever's in the numerator there. So your C is going to be 1001 deer. Okay, and then the last problem. So we have this 1,200 students. These Bob, Carol, Ted, and Alice start a rumor, which spreads logistically, and this is our equation, models the number of students who heard the rumor at the end of day t. So how many students have heard the rumor by the end of day 0? So day 0 would be talking about our initial. So if we plug in 0 here, so when you do that, that's really just 1,200 over 1 plus 39. So 1,200 over 40 would give us 30 students. And then finally, how long? So we're trying to find t. Does it take for 1,000 students to hear the rumor? So in other words, we're trying to figure out when it's equal to 1,000. So once again, because we're trying to figure out when the two things are equal, we're going to put this in our y1 and our y2. So I'll let you try that. So you're going to go y1 and y2. I would change your y max to over 1,000. You can leave your x max at 100 or would be good. So then you're going to find where they intersect. So just try that, and when they intersect, you should make sure you can get 5.859. And then this is in terms of days for our time here. So you're just finding where they intersect on your calculator. So those are just problems with exponentials and logistics and how they can be used with real-world type word problems.